Hello YouTubers, Charles here, and welcome back to my How I Design Factory Blueprints video. Making a factory that will produce everything we need for a solar panel blueprint that has solar panels, accumulators, row ports, and substations. We have the basis of this factory in, and it is processing oil and also producing the accumulators. But now we need to design the rest of it that will make the solar panels, substations, and roboports. So let's get to that. Alright, we're going to need green circuits. So I'm just going to copy a green circuit production that we currently have. And we'll make do. I think that's a little more stuff in there than I want. We'll build this off to the side, and go from there. We're gonna need at least 3 belts. Okay, I don't know what you are, but you don't go to anything. Let's get this working, and I can explain how this works. Okay, get power. You will be on place. You are on place. And that is green circuits out. That should be almost a full blue belt. Now, circuits need a lot of wire. One plate makes 2 wire. And yeah, we need a whole lot of wire. You can see this is almost dropping to 0. In fact, the machine does stall production at certain points because we can't get it wire fast enough. So we have direct transfer through boxes, which is the fastest. You can see we're dropping 12 at a time. They're immediately being picked up and put in the next box, which is immediately being picked up and put in the next box. But we only have 1 space here of which we can do that. We kind of need 2 rows of this. So to supplement that, we have blue belts of additional input. But even that isn't quite enough. On occasion, the wire machines will stop, maybe? Or maybe I just... Oh, yeah, there it did. I didn't catch if it was out of plates or out of wire. I mean, if it's out of plates, that's easy to fix. It should never be out of wire. Let's see if we can actually improve this. And make something much more complicated than it is. Let's let this run out of wire. And we're doing 2.4, 2.5 a minute. Just get on both. There. And help make sure we don't run out of plate. Alright, now if we hit productivity, Somehow that's worse. I'm guessing the boxes don't get a full load every time now. And that's where we really want our cable to go through the boxes. Okay, we need 7,220 green circuits per minute. So, we need 3 of these. And of course, I like sticking everything right next to each other because it's convenient. Or at least that's what I tell myself. Luckily, sticking 3 of these down next to each other works out. Barely. It does. And there we go. Seven 7.3, 7.4. More than the 7.2 we need. And if I actually do a whole minute. Yeah. That's gonna work out for us. 7.4 average, more than we need. Not sure how we're gonna do this though, because this needs to go. Mostly, it's needed by 9 assemblers of solar panels. However, we need to split off a little bit to make red circuits. The red circuits aren't the problem. For me, the problem is how do I get this into 9? How do I fit 9 along here? I mean, we could do 1, 2, have 3 hanging off. 1, 2, 3, and then 1, 2, 3. Maybe have the red circuits around there as well. I mean, routing the green circuits will be weird, but that makes sense. Will be our solar and control. Solar is going to be trouble because, one, it needs a lot of circuits. How long is the craft? Well, it's 10 seconds, but it needs more than 1 stack inserter per craft. And what is our crafting speed? 600%. So in 10 seconds, well, it's not down to 1 second, but it's less than 2. I'm not sure how fast these rotate. I don't think 1 would be able to keep up. So now we need an output, but we also need 2 other inputs that need to fit in here somehow. So basically I need like 2 belts on this side, both of which get picked up. And I do know there are ways of doing it. I'm not just sure what's the most efficient. Not even sure if I need that, but so like this will work. And we'll just so this is the one input, it gets split and picked up, and then the other one is picked up off the inbound. Okay, yeah, that will work without a belt. And then this can be our output. So with those, and so we copy this. So that's copy is correct. Why don't you? Okay, yeah, did it go there? I need to fix this. And so copy this now. That. Now how? We got 3 here, and it would be nice actually if I could like reverse the order of this belt, so that came out over here. But like I said, it would be nice. There's alternates that I can see. I mean, I can just do this kind of a crazy. And switch this around. Need to go like that. That. So we're just looping it over here and then coming this way, ending there, because that should basically use up all that. And I copy this one. We have there. So we'll do that. And that's basically the same thing. The problem is we want to break off a little bit of these green circuits here. Yeah, do that. Like that. And we just gotta power these from this side. Okay. We need red circuits. Red circuits need green circuits. We need 3 red circuit machines. Red machine. Sweet. This is we only need 470-ish green circuits a minute, and that's easily filled by one side of the belt. We need copper, though. Copper wire. Luckily, normally you want to direct insert copper wire, but again, we need less than 1,000, and that will also fit on one side of the belt. And this is crazy. Should not break them. It's gonna be a crazy layout. What we don't want though, we want productivity. Safety for you, to make sure we need 3 of these. This one. Now we need 1 more input and 1 more output. Additionally. The 1 more input is the plastic. Probably use fast inserters, but I'm just going to use stack to be safe. And plastic. I'd like to run plastic down here, so how do I get it over here? I mean, I guess at worst, we don't use a splitter, and then we just run the plastic by the copper here before getting it to the last one. And that works out. We just need inserters. I only have 1. We may need 2, but we'll have to see. See, now conveniently, we have a 3 wide space here. And this is 3 wide. So we can just plop that down here. And look what happened. We have 1 space here. We need plastic. And if I look at my chart here, plastic only needs 1 space. You need to be there to be centered. You're going to be plastic. And we need to give you some productivity modules. Now I was hoping something like this would work out. But I, did not have this all pre-planned. Plastic is only required, so it's not use. We need full oil. That would work. That's using there. So let's check on red circuits. We need about 325 a minute. I'm gonna say we do have that. But let's get our solar panel production underway. That's what comes out. We need these 2 things. We need copper. And we need steel. To turn those around, because that's completely not right. There's our solar panels. As long as the green circuits keep up. Which it does look like they are. Um, this is almost a full belt. You see it does stop occasionally. It's 22 or 2300 a minute. 2250 is the actual number, but that's for 8.6 of these. We have 9. Let's look at the production numbers. Well, these are... well, that's ramping up still. But yeah, red circuits, we needed, or we wanted 225 a minute. And yeah, we got, not 225, 325. We got 335 right there. Solar panels, we have 450 a minute. Accumulators, 375 a minute. We wanted for them 450 a minute for solar panels and 378 for accumulators. A little short on the accumulators. We can try to look into why that is. And we're a little short on the solar panels. But both are, oh, here, now this is back 370. Both of them are really close to the ballpark of what we wanted, which is to make half of one of these there's 2 here, a minute. And yeah, that's actually pretty small. We could double this in place just by putting 2 of these down. But we're not quite done yet. There was 2 other things we wanted to make. And actually both of them are going to be relatively simple, I think. I hope. Neither of them need to be beaconed, and they can all both be blue. Blue assemblers here, and like I said, they don't need to be beaconed, but we have beacons right here. They don't need to be beaconed, and it might actually be more trouble if they were, because one would take too many items, I think. So those things are RoboPorts, if I can find it. There we go. Not quite used to the new look yet. And substations. Also not used to the new look. Both of these need the red circuits. So I'm going to run those like that. And we're going to use some long-handed inserters. However, they also both need steel. How can I get this steel over to here? Well, I mean, we can go the long way. Each of these, though, needs one other item. Now we need gears for the RoboPort. And I'm gonna need to get you iron somehow. You need copper plates. Luckily, copper plates aren't too bad. We could borrow the iron from here. Or, how much iron are we using for our sulfur? No, because that was already mathed out to be just about perfect. I think. Yeah, this... that never stops. Whereas, on the other hand, you can see these do stop occasionally. So there's spare supply here. It's just getting it to where we need it. Don't see a real easy way of doing that, unfortunately. Okay. Okay, let's get an output. We'll put these both on the same. Need some power. Yeah, that's not gonna work. We can actually control how quickly this runs by how many gears we make. We want 225 gears a minute. We kind of want you, I think, just so we can have the productivity. Why does this say we're only making like 84 a minute? Because if I look back, it's probably needed to be speed moduled to only be 0.2. Yeah, yeah, if I say, okay, we need to move this somewhat. Not actually very far, even. We need to move this a little bit. And this now is all of this. So if I go like that, and hit Q, delete that. So now this is being hit by 1, 2, 3, 4, and it itself is productivity, so it should only need to run half the time, even. Yeah, you can see we're making like a few, well, let's say a lot more than we needed. We needed 225, and it's above that. Let's gonna be close to 400 average, although it is now dropping. So we're actually going to be making more RoboPorts than we need, which means we'll be using more red circuits than we need. If I have only one arm, what does that do? Okay, that is better. It's closer to 300 now. Which means we won't be crazily overproducing these. So if I go to a full minute here and just highlight what we're actually trying to output. Okay, the other one's not actually... We're doing like 8 of these a minute. 7. Where I really wanted, 5. But that's not too bad. Let's actually have this all be being sucked up here. So we want 20 of these substations a minute. And somehow we're doing that as well. Well, no we're not. We're down to... Oh yes, we will. And that's dropped to 6 a minute for the RoboPorts because it's... The red circuits now are being used up. So if we let this run a full minute, this should be pretty close to what we wanted. And here. Alright, that looks like we have a full minute of production, and we got, well, down to 4 of these a minute. Because too many, like this is double what I want. So how can we slow this down more? I know one surefire way. Steel is used the most. If that's the case, we can do that. That might be too low. That's like 13 a minute. But we'll have to wait another 30 seconds or so to be sure. For the blueprint, we need 36 substations. So if we're at 18 a minute or more, but we're not. But we are at 6 RoboPorts. Do they get even? Should they get even amounts of red circuits? No. Now the RoboPorts should get about twice as much. Well, if this is satisfactory, we could split the belt into 3, give 2 to this, 1 to that, and that would be that. But 1 to 3 splitters we could do. Let's see how that does with a fast inserter here. looks like too much. But if we keep our row ports at 5, that would be fine. You know, a little high here. That's on the edge. Alright, what can I got? Alright, let's try one solution. This is a 2 to 3 splitter. But if you see, the two belts are balanced. So that should conveniently make it, this was an output, a 1 to 3 splitter. But because these two are merged, this should now get 2/3, or like... how do I get these... You know what? If I do that, that will work. So the row report should now be getting twice as much. That's 24-minute. Let's hit it on the minute. We'll have to wait a little bit because things were backed up a bit and kind of overproduced for a small amount. But that's looking good. We're at 6 or 7 roboports, and I'm still not sure how we're getting 30 substations out of that, but I'm happy with those numbers. So this is the base of our factory. The only thing missing here, well, besides all the trains and water hookups, like, we need some water, we need a little oil initially, so I'm probably going to put in, like, one normal oil, so we can just get a little normal oil in. Why is that there, especially with that being there? So I have to figure out how to hook this up to everything. But we're missing smelting. Luckily, well, not luckily, but I have pretty standard. What are you? Yeah, you're like a pretty standard-ish smelting, where the top here, these 4 rows all together are one belt of steel out of 4 belts of iron plate, not plate. Or it makes plate here, and then the inner 2 here make steel. The outer 2 make plate, iron plates, and then from the iron plates, the inner 2 make steel, and then that all gets merged onto one belt. And then these are normal. This is productivity smelting, where you have 2 belts of ore in, and you get 2 belts of plate out. So just by looking at how much we need of input, like this says, we need 1 belt of steel. So I can, copy 1 instance of this. In fact, let's do that. And, well, I'm not going to stick it down at the moment. It can be stuck down right here. The one thing you can see, though, is that it doesn't line up because this is compact. It doesn't have the space in the middle of every 12, at least horizontally. It does vertically. But I usually put the steel smelting at the far end, and let's just stick that down there. That's exactly how much we need. Actually, I apparently can't undo that. Let's redo, because I don't know what I undid. I want to turn this around, and then I'll stick it down, because I want the ore input here, because this is where we have the coal, and all our input trains will be here, or drop-off trains, and we'll have 1 pickup train, which I'm not sure where it'll go right now. It can go along the bottom, because we'll have this stuff here, and we can redirect these lines down here as well. The problem is, it's not a problem. It's just a little more math. Because I know, well, this needs not quite 4 belts of plate, and this says we need 7.2 belts of iron plate total, but that includes all the plate that goes to making steel. If I add up the iron plate that doesn't go to steel, let's do our little round numbers here. It's 800 approximately for the accumulators, about 1,500 for the batteries, about 500 for acid, let's say 5,200 for green circuits, and then 350-ish for gears. That's, I get 8,350. We'll make that a nice 8,400. Divide that by 2,800, which is a blue belt per minute, 45 times 60. And wow, that comes out exactly to 3. 45 times 60 is 2,700, not 2,800. My math was a little off. Times 3. Yeah. My math might have been off in a few places. Which is why we're not hitting that all the time. So we need a little more than 3. That's okay. On the other hand, we can use this for copper, the numbers off of the calculator. It says we need 3.6 belts of copper, so 4. And we'll do 4 for both, which makes things work out easy. One. Stop wood. And one is up here. Close. Okay, that is all the smelting we need. So we got 1, 2, 3, 4 of copper, 1, 2, 3, 4 for iron plate, and then oh, I copied too much. Look at that. That's not right. And then paste. So 1, 2, 3, 4 for copper, 1, 2, 3, 4 for iron plate, and then 1, 2, 3, 4 for steel plate, steel beams, whatever they are. And that all comes out here. There we go, that actually saves some complication. There's enough spare in the one line. We don't need a whole extra line. 1, 2, 3, 4. Hey, we run right into them. 1, 2, 3, 4. Oh, there's another one up here. Look at that. But 1, 2, 3, 4. We run right into those. We got to do some 4 to 5 balancer. And then here's our steel. That's relatively easy. Yeah, this one stops, actually. That's one. Which one's up like this? Alright, that's all sorts of not great. Alright, we want the pattern to look like this, so that the speed of these aren't affected. We only need 3.6 belts of copper. So the fact that the one row of smelters is going to be a little slow, because they don't have their things lined up, is okay. It shouldn't... It shouldn't slow it up more than, like I said, the 0.6. Hopefully. That's the plan, at least. I probably should have a 4 to 4 balancer, though. Which is just your standard balancer. So yeah, this is what this is going to look like. Now it's just building trains on this side and running the belts on this side, which, I mean, could be a whole process in and of themselves, but that's more straightforward than what I've just done. You know, we'll take these 4 here, run them into here. One will go straight. We need a 5 to 4 balancer. Okay. I mean, that's not much different. We get out the balancer book. I did not design this. This is something I have copied off of, well, it's probably the Factorio forums, but you can find versions on Reddit or probably the wiki. So we got 4 coming in. 1 will go here. Why did this stop? Oh, because it never started. When I copied and pasted, there's obviously no heavy oil, which is, like I said, why I want to stick one of these over here. But that's, like, we need, like, a little delivery of oil to get this started. Anyway, 1 will go here, the other 4. 1, 2, 3, 4. The iron will have a 4-to-4 balancer. And, well, 1, 2, 3. 1, 2, 3, 4. We're gonna get away here, so. There's the iron balancer. We'll have the copper come down here. The one iron will connect up to there somehow. The steel will then doesn't need to come out that far. Route the steel over here. The 2 outputs we can then bring over here. We'll make a train stop. That's my process. It's probably took way... Well, I mean, I know it took way longer. It's probably going on over 3 hours for me. I hope I'll have edited it to something more reasonable for you. Maybe it'll be a 2-parter. So yeah, that's my process. Thanks for watching. I'll see you next time when we're back in the actual map and probably putting in more outposts to get some more science factories going. See you then. Stay safe. Wash your hands. Thanks for watching.